Warahmatullahi wabarakatuh. Welcome back. Okay, we are going to continue this topic, by talking about the topic of impulsive motion. Okay, if you look at this figure, this is, I think, few of you maybe you play, play cricket or play baseball, softball, okay, hockey. Is that those games they are very much related, or tennis? Okay, we have what we call this impulsive motion. Okay, so for impulsive motion, what does it mean is it is basically a force, okay, that act on the particle during a very short period of time. Okay, someone throw you the ball and then you hit, okay, the ball at a very short period of time, okay, time interval. But it's large enough to cause a significant change in momentum. Okay, so what you can see here, um, we have here MV1, and then this is F delta T, okay, F delta T. And then we have here MV2, okay. So the impulsive force, okay, the impulsive force act on the tennis ball here. We can use this equation, which is a MV1, okay, plus summation of force, okay, we have delta t. This is what we call a very short time interval. Normally a few seconds, only 0.01 seconds, something like that, okay, or less. And then equal to mv2. Okay, so this is what we call impulsive force. Okay, impulsive force. All right. If a non-impulsive force, okay, so we can neglect. It can be neglected if non-impulsive. So which is F delta T. Okay, this one we neglect and drop out. So it will become this one. When this one drop out, only these two equation remains. Okay. All right. Now we want to proceed with an example of Bias and Johnson books. Okay. In this problem, we have the car. Okay, the weight of this car is in kilogram. Okay, it driven down. Okay, driven down at an incline of 5 degrees. 5 degrees, and you have the speed here of 96.54 kilometer per hour. Okay, going down the hill. Okay, speed 96, and then what she did, she applied the brake. Okay, and it caused a constant total braking force is 672 Newton. So the question asks what will be the time required for the car to come to a stop. Okay, use this principle. Okay, so in this problem, it's been specified that you have to use this principle. Okay, the principle of impulse and momentum. Okay, so we can use this principle. All right. So we apply the equation that you have used or been exposed earlier, okay, which is MV. Okay, this equation we have MV. MV. Okay, MV plus impulse function. Okay, impulse from 2 here, and then equal to MV2. Okay, so we have a datum. Okay, so the datum here. Okay, take this one and this one. All right. So you start writing. Okay, going down is positive this way, and then going up positive. 5 degrees incline. Okay, so first thing you have to draw the diagram. Okay, the diagram that I have, the one that we have used before. Okay, draw this diagram. Okay, follow. You need to know the initial and then impulse. Okay, and then final. Okay, same thing here. Okay, so what you will do, we have initial here, MV going down, and then the impulse we have. What do you have here? The impulse. We have the body weight here, right? We have the body weight going down, body weight going down at the angle of 5 degrees. 5 degrees. And then what else? We have the braking force there, right? And then what else? You have normal force. Okay? You have normal there. Okay? And then this is weight. This is weight. This is normal. Okay? Okay, and then before and after. This is in between. This is before. This is after. Okay, B. Okay, this is MV1. MV1. And then this is MV2. What is the value at MV2? Anybody knows? Anybody want to respond? What will be the value for
0.
Zero.
Zero.
Y 0?
Stop.
Because we apply the brake, right? If it's not zero, you're going to hit someone or kill somebody or you have an accident. Okay, so causing a constant brake, stop, complete stop. Okay, going to be zero. Okay, so simply you just uh, by doing this, okay, you draw the diagram by applying principle of impulse and momentum, which is this one. We have this one, mv, f, dt, and mv, right? So this is the free body diagram that I have shown to you just now. So this is very important. As I mentioned earlier, the topic of the free body diagram is the fundamental one. If you did this one wrong, the rest will be wrong. Okay, wrong. So make sure you do this right. Okay. So we set the datum. Okay. So you get MV and then here plus minus. So plus this way. So plus sine 5 degrees, mg, and then minus ft, okay, braking force, equal to 0, okay. And then you substitute the value there, you get, based on the information you have just now, m is kilogram, this one is in kilometer per hour, right? So you convert, right? Do the conversion, right? So that you have a consistent value. And then you multiply mv velocity and then plus 100, 1814.4 times 9.881 sine t. Okay, and then force, braking force. This is braking force. Huh? This is referred to braking force times t. So you solve this, you get t equal to 9 seconds. This one you convert. Okay, you convert it from kilometer per hour to meter per second. Okay, this one is a braking. Okay, I think this one very straightforward, not difficult. Okay, we proceed to the next example. quite similar with the earlier one, but the only thing is we have to apply the concept of impulsive force. Okay, impulsive force there. Very short time, short period of time. Okay, so for this problem, this is we talk about the baseball player. Okay, sample 13.4. Okay, the ball, the 113.4 gram. Okay, is pitched with the velocity of 24.4. Somebody throw it to you this way, 24.4 meter per second, and then this batsman hit at the angle 40. Okay, going with the speed of 36.6 meter per second. We have with the velocity of 36 meter per second. Okay, so this one we have the velocity of 24.4, and then after being hit, it has the velocity of 36.6 meter per second in this direction. Okay, this 40 degrees angle. Okay, what's other information that we know over here is the bat and the ball are in contact for very short period of time, okay, which is 0.015 second. Okay, so the question asked here is to find the average impulsive force exerted on the ball during the impact. Okay, what will be the average impulsive force exerted on the ball during the impact? Okay, so again we use the principle of impulse and momentum. Okay, so again we draw the diagram. What will be the diagram? We start with the first one, this ball plus the second ball. Okay, oh, supposed to be the same ball, no? Same size. Okay, so the first one, which is MV1. Okay, so we have MV1 here. Okay, MV1. Okay, MV1, and then here this direction, going to this direction, and then after being hit, going to have with the angle 40 degrees. Okay, so you have MV2. Okay, see what happened here? We have impulse here. This impulse, this direction, and this direction. Okay, so we have Fx, short period of time, delta t, and then we have Fy, also delta t. Okay, this is the first one, first diagram. Next one, you have to do calculate the x component and y component. Okay, the x component and the y component. Okay, y component, the x and the y component. Okay, all right, can you do that? Let's start with the x component. Let's start with the x component. Okay, you put everything together, right? We have minus mv1, right? Minus mv1, and then plus fx delta t, right? And then we have
equal to MV2.
mv2 sine or cosine?
Cos.
Yes,
Cosine.
cosine 40, right? This is first equation. And then for y component, we want to write y component, we don't have mv2 here, which is 0 plus fy
Fy delta
component
T.
delta t equal to
MV2 sine 40.
mv2 times sine 40.
40.
Okay, and then from here you can solve. Okay, we have this one equal to 1 equal to 2, you solve, you get fx, and then you get fy. Okay, all right.
Patch notes are out for the new 1.1 update in Chinese, and Reddit has translated it as always appreciated. This confirms that child will be with the league banner of the 4 stars, so Ni Huang, Beto, and Fiona. Banner will last till December 1st, in which case Sullivan's banner will be and likely the same 4 stars of Xi Gang, Razor, and Chong. This also means that my Chow won't arrive until Christmas time in May, as each banner lasts around 20. The new events, however, will not start at the launch of 1.1, but instead.
Yeah. Okay, I continue. That's what we call parallel processing, right? Doing so many things at the same time. As long as we have many ears, you can absorb, no problem, and can answer the exam question. Okay, we have done this one. Next one. This is the solution for that one I have elaborated just now. And then what you obtained just now is the direction of it. This is the important thing that I highlight. One thing is use this equation, and then you put together everything of x direction, okay, and then y direction, and then you get the value of fx and the value of fy, and then you put all of this in ing form, okay, and then the magnitude of it you get for 34.5, and then this is how you draw the, di- the diagram of it, okay, in this form, okay. The tangent of this one is 24, inverse tangent of y over x is 24.2, and then you get the magnitude of it is 434.5, okay. Okay, this is about principle of impulse and momentum. Okay, we have done this example 13.11. Okay, in our next topic or next session, I'm going to elaborate other topic, which is principle of conservation of linear momentum. Okay, so we're going to take another 5-minute break.